Good morning everyone. Today we're going to talk about the forces acting on an airplane and especially why is an aircraft able to climb to desired altitude. So basically this image represents an aircraft in a cruise state, so in a steady flight, and we can see that there are four forces acting on it. This is lift, of course, weight, those two forces that I talked about in the previous videos, and this is thrust and this is drag. So this is the normal situation, so basically where an aircraft spends most of the time, hopefully. This is the cruise phase, and in this situation the aircraft is not accelerating, it's in a steady flight speed because all these forces are balancing each other. So if we consider instead an aircraft in a climb, this image of course now represents an aircraft established in a climb altitude. Of course I forgot to mention this is the center of gravity. This is named the center of gravity, which is the point through which weight acts and through which all of the three axes of the aircraft pass through, which is the longitudinal, the vertical and the horizontal axis. It is always along the flight path and it has forward and aft limits, but we're not going to talk about that today, maybe in another video. So basically in a climb altitude, a component of the weight is going to act backwards and is going to be added to the drag. If these two forces now are not balanced by thrust, then the aircraft is going to decelerate. But if there is excess thrust, which is the thrust available after the aerodynamic drag has been balanced, then the aircraft is going to reach a steady flight speed. This excess thrust is always available, even on one engine in operative situations. Of course, the climb gradient that we're going to look now is going to be shallower, but is still positive. So yeah, basically the more excess thrust we have, the greater the climb gradient, or the greater the force of weight, the greater the weight that we can add to the aircraft. Let us now consider an example here that the book gives us. So basically, the climb gradient is going to be the maximum component of the weight compared to the thrust. And we can calculate that. So the formula for the climb gradient is thrust minus drag divided by weight times 100. So let's say, for example, that an aircraft has a twin turbojet aircraft has engines of 60,000 newtons each. So one engine, 60,000 newtons, right? So twin engine, of course, both engines is going to be 120,000 newtons. And it says here to consider G as 10 meters second. So we're gonna use 10. And it says that it says that this aircraft has a lift to drag ratio of 12 to 1. So lift to drag equals 12 to 1. And we know, of course, that lift is going to be equal to weight. So weight is going to be 12 times the drag. And now the only thing that remains to calculate is the weight, and it says that the aircraft weighs 50 tons. So 50 tons, 50,000 kilos, right? Times 10, 500,000 newtons. And we know the drag is going to be 1/12 of 500,000, which is 41,667. So now the formula is easy. We have all the figures. It's going to be the thrust, which we said 120,000 newtons, right? Minus 41,667, correct? Divided by the weight, 500,000 times 100. And it gives us, well, 120 minus 40 says, 78,333 newtons divided by 500,000 times 100, 15.7%. Cool. And then the book does an example with only one engine, so 60,000 minus 41,600, and you can still see that it's positive because it would give us 3.7% as the climb gradient. So I'm happy and I'm hopeful that you enjoyed this video and that you now understand why an aircraft is able to climb and how to calculate the climb gradient of an aircraft. I mean, you're learning pretty much damn good stuff, isn't it? Cool. See you in the next video.